My name is David Michael. This is BCH 410 Enzymology 2. I want to believe before now that we have gone through Introduction to Protein Chemistry, Enzymology 1. Okay, so moving on this course, we're going to be doing quite an extensive study of enzymes, and we're going to start with the first block, which we talk about enzymes and enzymes active site. We're also going to talk about the regulatory sites, and then how to identify the active sites amino acid groups. And then we would also talk about the mechanism of action of some well-known enzymes, including chymotrypsin, lysozyme, glutathione reductase, the pyruvate dehydrogenase complex, the bovine pancreatic ribonuclease A, and then alcohol dehydrogenase. Okay, so that is that for that block. And then moving on, we would also talk about the mechanism of bisubstrate enzyme reaction, study quite extensively the sequential and the non-sequential bisubstrate reactions. And there are a couple of equations in that block of lecture, but when we get there, we'll deal with them. So moving on to the third block, we'll talk about transient enzyme kinetics, talk about pH and enzyme catalyzed reactions, temperature and enzyme catalyzed reaction, energy activation, then the Arrhenius plot. And then to the fourth block, we'll talk about the steady state enzyme kinetics to include mechanisms of equilibrium binding and binding equations, including the Scatchard plot. Okay, and then lastly, on the last block, we'll give some detailed treatment to the behavior of enzymes. There will feature the Hill plot, the Adia plot, the KNF model, the MWC models, and we'll also study some examples of allosteric enzymes, especially the aspartate transcarbamylase, the pyruvate, the protein kinases, and then the phosphofructokinase. So this will be our guide for this course. So I really want to encourage us to stay tuned and follow through. You're going to enjoy yourself, I can assure you.